Welcome back to our course in trigonometry. Dr. Tom McNamara here again. In this video we are going to discuss proving trig identities. Now this, if you go way back to the beginning of the course, I said there were three big things in trigonometry. Three reasons that trigonometry is useful. Number one was indirect measurement. We're actually going to talk a lot about that when we get to right triangle trigonometry. The second thing was modeling periodic phenomena, and the third thing was the algebraic relationships that the trig functions fit into. And that's kind of what we're discussing right now. So, proving identities. So just a few notes about the principles that we should use when we're proving these identities. We'll typically start with the left side. In general, whatever side's the more complicated, that's the one we start with. But for these ones that we'll do today, it's going to be the left side that's the more complicated side. So we're going to start there. We're going to rewrite all the functions involved, rewrite everything using sine and cosine exclusively. So in other words, if you see cosecant in the mix, well, you use your reciprocal identity. Replace cosecant with 1 over sine. If you see tangent, replace tangent with sine theta over cosine theta. And then once you've done all the replacements, simplify as much as you can using some algebra. Okay, let's do a couple quick examples. Okay, so prove this is an identity. Okay, so this is going to be sine theta times cotangent theta equals cosine theta. All right, so this is what we're given to prove. We are supposed to establish that the expression on the left-hand side of this equation is equal to the expression on the right-hand side of this equation. So in a problem like this, the answer is our work. It's the line of reasoning that we use to transform this expression over here into this one over here. So let's just follow our principles right here. I'm going to start by rewriting the left-hand side. Sine theta times cotangent theta. I'm just going to write it down again. Now, I'm going to rewrite using exclusively sine theta and cosine theta. Okay, well that's already done. Sine theta. Now cotangent theta, I can use my ratio identity. Cotangent theta is cosine theta over sine theta. Sine thetas cancel each other out. We're left with cosine theta. So I've taken the left side and I've shown that I can transform it into the right side, proving that these two expressions really are equal for all values of theta. Okay, let's do a couple more. How about we try... Okay, I had a nice one here with some fractions. Okay, here's kind of a complicated looking one. They're asking us to show that if I take sine theta plus cosine theta times cotangent theta, that I'm supposed to get cosecant theta. Okay, so, well, that's getting way out of focus. Oh, it likes it when I'm in the frame. Okay, so once again, start with the left-hand side. So we're going to do this: sine theta times sine theta plus cosine theta times cotangent theta. So we just write down the left-hand side again. This is our starting point. This is where we want to end up. Now I can't do that right away. Don't write this down yet. We're not justified in jumping to cosecant yet. Here's the way I want you to do these. Rewrite everything using exclusively sine and cosine. So sine theta plus cosine theta, not cotangent though, we're going to put cosine theta over sine theta. Okay, so sine theta plus cosine squared theta over sine theta. Okay, where's the cosine squared coming from? Well, I got cosine times cosine. That's what cosine squared means, right? Cosine times cosine. Okay, now I'm adding fractions. We're adding fractions. We treat that as sine theta over 1. What's your common denominator? 1 times sine theta. Take the denominators that you do have and multiply them. That's how you get a common denominator. So I got to hit this on the bottom with a sine, which means I got to hit it on top with a sine. So this becomes sine squared theta over sine theta. All right, no change over here. Now that I've got my common denominator, I can combine my numerators. So sine squared theta plus cosine squared theta over sine theta. All right, now we're thinking about our identities. I got sine squared, I got cosine squared. Think about your Pythagorean identity. Sine squared plus cosine squared is equal to 1 over sine theta. 1 over sine theta is, using the reciprocal identity, 1 over sine theta is cosecant theta. Okay, so we started with the expression on the left. Rewrite everything using sine and cosine exclusively. And then we're doing algebra. The previous example was pretty simple. All we had to do was cancel a common factor there. Here we got to do a little more work. We're adding fractions. You're adding fractions, what do you got to do? Get your common denominator. Okay? Now once we did that, we're seeing sine squared, cosine squared. Sine squared plus cosine squared is 1 by the Pythagorean identity. That's how we simplify that numerator. And then we see 1 over sine theta. Well, we know that's cosecant theta. So we can take the left-hand side and transform it into the right-hand side. Now, what I'm looking for when I grade a problem like this is I am looking for these steps, okay? The whole point is the process of going from the left side to the right side. Okay, now why would I ask a student to do this? Well, one, I want to make sure that they know their basic identities, the reciprocal identities, the ratio identities, the Pythagorean identities. Okay, and if you really know those, then you can see when you can make these replacements and simplify one side into the other side. Okay, the good thing about an identity is you know your target. You want to make this thing equal to cosecant. So typically we start on the left-hand side, which in this case was the more complicated side. That's what you want to do. You want to take the more complicated side and simplify it into the other side. Okay, so a couple of examples of proving identities. Remember, start on one side, replace everything using exclusively sine and cosine, then you start working your algebra. Okay?